Hello, in this video we will discuss about Aharonov-Bohm effect in great detail. In classical electrodynamics, the scalar and vector potentials are not directly measurable quantities, but the measurable quantities are electric and magnetic fields. In 1959, Aharonov and Bohm proposed an experiment in which beam of electrons is split into two and passed either side of a long solenoid before they are combined. The beams arrive out of phase, which depends directly on the vector potential. This phase shift is a measurable quantity. They showed that the vector potential can affect the quantum behavior of a charged particle even when it is moving through a region where the magnetic field is zero. So I'll give detailed explanation. Imagine a particle constrained to move in a circle of radius b. Along the axis runs a solenoid of radius a, which is less than b, carrying a steady current I. So you can see the charged particle on a circular ring through which a solenoid passes. If the solenoid is extremely long, the magnetic field inside it is uniform and outside is zero. But the vector potential outside is not zero. It is directly depends on the magnetic flux through the solenoid. For this particle, we will write the time dependent Schrodinger wave equation. So we have the Schrodinger wave equation given in equation 2, where the Hamiltonian written in a form which is nothing but a charge for a charged particle in an electromagnetic field. The solution for this time dependent Schrodinger wave equation can be written as equation 3. Here we have a phase factor and psi dash combined form a solution. So G of R depends on the vector potential. The psi dash satisfies the Schrodinger wave equation without a vector potential. If we can solve this equation 5, then the solution will be just attaching the phase factor e power ig to psi dash. So now Aharonov and Bohm proposed an experiment in which beam of electron is split into two and passes either side of a solenoid before being combined. So the electron beam splits and with half passing either side of a long solenoid. The beams are kept well away from the solenoid itself, so they encounter only region where magnetic field is zero but the vector potential is not zero. The two beams arrive with different phases given by equation 6. The plus sign applies to the electron traveling in the same direction as the current and the negative sign opposite to that. The beams arrive out of phase by an amount proportional to the magnetic flux given by equation 7. This phase shift is a measurable quantity which depends on the magnetic flux, but the magnetic flux depends on the vector potential. So the vector potential is a measurable quantity. So to conclude, the vector potential affects the quantum behavior of the charged particles and it is a measurable quantity. This is known as Aharonov-Bohm effect. Later, Berry has shown this Aharonov-Bohm effect can be regarded as an example of geometric phase. I will make another video on this, how this Aharonov-Bohm effect can be considered as an example of geometric phase. Thank you.